sensor interface using Wokwi simulator. As in the previous video, we have seen Arduino how to use ID in the cloud web editor here. So it is similarly to the offline editor only, but you can include now easily your libraries directly searching on the internet, and directly you can include and you can have an interface here. In the same manner, Wokwi has done job easy. Before implementation of any hardware using Arduino interfacing can be simulate the same scenario in the Wokwi simulator here. So today we will see ultrasonic sensor and interfacing with the Arduino or ESP32 here. Okay, so at the learning outcomes are at the end of this session, students will be able to use Wokwi simulator for interfacing various sensors here. So for this, now we will go directly to the Wokwi simulator web page here, and we will see how to use and how to implement the simulation, so that you can take the simulation reading and you can compare with your practically implemented circuit here. So before doing any practical implementation, you can simulate all the things so that your things are going to be in the correct manner here, so that your time is not wasted for using directly on the Arduino and the real-time sensors here. Okay, so for that thing, we will go to the Wokwi.com here. So in this page, so you will be having the simulate with the Wokwi online here. So same way the various Arduino boards are available on the market here, like Uno, Mega and Nano here. ESP32 is there, SMT32 and Raspberry Pi also is available, that is a Pico board here. So you can integrate Wokwi with the VS Code, so you can have the code whatever you are going to write in the VS Code, and you can directly integrate with the Wokwi simulators here. Okay, and popular languages used for the Rust, micro Pythons are there for your starting your project here. So these are the some features projects are there, like MQTT protocols using a weather logging here. So this is an joke machine or ESP NTP clock, that is a real-time clock you can have. Simulation projects like Simon games, 32x32 LED matrix here. If you go there, so you can have the Mega board connected to the LED 32. So this can be implemented here. Okay, directly you can simulate, and the same thing, the code is also available. Whatever the logic you are going to do change, you can directly change here, and you can directly burn into this Arduino Mega, and you can check your result also. So same way, today we will see the two interfacing of the ultrasonic SR4 with Arduino and ESP32, and one more if the time permits, we can have the interfacing of an DST11, that is the temperature and humidity sensor interfacing with Arduino and ESP32 also. Okay, so for that thing, what we are going to do, just you have to go to the Google and Wokwi ultrasonic sensor, you can type here. If you type this, so you will getting this first example here, so directly you can go there. Okay, so like Arduino web editor here, so here we are having the code written, so INO file, you can download it here. Okay, so from save a copy or download project zip here, or you can share also. Okay, so you can give your name, whatever the name you want to that, you can directly give the ultrasonic.ino, whatever the name you want. Okay, and you can sign up. Okay, so now if you want to add Arduino board or ultrasonic here, how you are going to do in the Wokwi simulator? For that, you need to add some new part. You have to click on this plus signature. If you want to click here, so you can have the whatever you want, you can add those. Now suppose if you want to LED, so the various types of LEDs are available, that is red, RGB LED, OLED, laser dot matrix here, LED bar graph and all those. Suppose if you click on this, so this product will be get available here. And if you want the information about this LED product here, you can click on the question mark. So you will be getting all the information about the Wokwi LED bar graph, how it has been working, what are the pins are there. So this is the anode positive AN and CN cathode positive, means what, which pin should be connected to the Arduino board here, that is been given here. Color is what, the color of LED body is YGBR, that is the red here. And attributes, if you want to change the code color, that is yellow, this is the hex value for the green color, YGBR, BCYR here. Okay, so you can use this library also. So the strong support is there from the community of a Wokwi, so you can use this. Okay, this is now suppose if you want to know about the Wokwi HR SR04, that is an ultrasonic sensor which has 4 pins, that is the VCC, trigger pin, echo pin and ground pin. So before doing all this, you should be able to understand what is the basic principle of an ultrasonic sensor here, how that basic sensors are going to work here. Unless and until you understand that, you will not be able to interface that pins to the Arduino board where you are going to connect it here. So VCC means it should have 5 volt supply here, so that's why VCC is there. So this pin, pulse start to measurement here, trigger pulse, and echo measure the high pulse length to get the distance. So the basic principle is what, whenever you are going to measure the distance, first the trigger pin will send some signals, it will be get back that signal through an echo pin. So when there is a destruction of the distance, so you have to measure that distance here, and the ground pin here. Okay, so initial distance value will be given in the centimeters here. See here, all the operations are given. To start a new distance measurement, the trigger pin for a high, that is 10 microseconds for or more will be there. So you need to understand this. So this is the basic principle. Okay, if you have to get in centimeters, inches, setting up the distance, this is the code here. Okay, so examples are the distance sensor, LED, and all those things here. Okay, so all strong support is there here. And now same like an Arduino, what we have defined, that is echo pin 2 and trigger pin 3 here. So that has to be get connected here. Now if you want to get the information about the Arduino also, you can click on this question mark. So you can get all the pins where the pin numbers are there. Pin number 13 is SPI pin, 12, 10 and 11. I2C pins are there, A4 and analog pins, and A1, A0 to A5 are there, 6 analog pins are there, and 13 digital pins are there here. And you can have RX, TX on that here. Okay, and you can interface this. So the baud rate at which you are going to have the communication, so that is serial dot begin, that is 1,15,200. Pin mode, that is a built-in and output mode. Trigger pin will be an output, echo pin will be input. So whenever you are going to send the pulse from the trigger pin, you will be getting that back pin, so that will be an input pin. So trigger pin will be an output pin here. That pin has to be connected 2 and 3 here. Okay, this pin has been connected to here, and red color pin is connected to VCC, and this black color is being connected to the ground here, and 2 number pin, that is echo pin, is connected at this point, and this so you can connect this pin. Okay, 3 pin to the trigger pin here. So if you want to calculate here, so you know the formula, that is 0.034 here, that is 340 meters per second the sound will travel here. So that has been converted into this, so 0.034 divided by 2 here. Now you have to write the whatever the function you have written, read distance m, so it will be called and it will be taken here 10 seconds, 2 seconds, because 10 microseconds of distance should be more here, that pulse here. You are going to read all this value. Now suppose if you want to simulate here, so what is the program is written here? If it is the distance is less than 100, your LED is going to blink. Otherwise your if the distance is more than 100, your LED is not going to blink here. In the same manner, if you want to simulate, you can see the output also. Here there is no any chance of getting any damages here, because we are going to do all the simulation here. So for you can easily implement, and you can copy this code, or you can directly burn this code using Arduino web client, web browser, that is cloud, through your original board here. So for that you are going to simulate now. If the simulation is there, the distance will be okay, so 177 here. So if you click on the ultrasonic sensor here, so now you can increase the distance or decrease the distance. If you are going to increase 278, your answer will come in that range. So maximum you can have the 400 centimeter, because that is the distance measured by the ultrasonic sensor HC SR4 here. Okay, So what I have told you, that if the distance is less than 100 here, so what will happen, your LED is going to blink here. See that now LED has been blinked here. Okay, so if you increase the distance, as the LED will stop glowing here, and if you are going to have the distance less than 100, you are going to have the LED thing here. So in this manner, the efficiency and this how much time you are going to run, all these things can be taken into account here. If you want to delete, you can delete this these buttons. Now you can plot the actually graph also. Okay, so if I can have LED glowing, see now I am going to change the values, so it will be remain constant if the same distance you are going to get. So if I am going to change, it will be changing here. Okay, so you can stop here. Okay, so in this manner you can use the Wokwi simulator here. So similarly, if you want to use the HRSX4 with the ESP32 here, that is another board like an Arduino board where the Wi-Fi is also there here. In the same manner, you can see the diagram, so how the values are going to be sent here. Okay, and the library manager, which are the libraries are going to be included here. So that can be seen here, the diagram, how the JSON format is used to send the data, ultrasonic edge.c libraries. So these are the libraries always included in this form here, that is std, this all these files are being included here. Okay, so same way if you run on this, so you will be getting the distance. You can change that distance also. Now it is less than 1.5. now this. Okay, so in this manner we should know how to use the Wokwi simulator here, and when in the first video lecture also we have seen the Arduino cloud editor here, how we have to use for the programming here. Okay, so these are my references. Thank you.